Many of you guys should know Ted. He's been with the Spark community for a very long time. He's one of the original authors. He wrote the book on Hadoop, literally. He is a O'Reilly trainer as well as an author, and he currently is the technical group architect at Blizzard. Previously, before that, he was with Cloudera as a principal architect, and we're really excited to have him here today. He flew out all the way from Irvine, California. How many people have read one of Ted's books or attended one of his training classes? Hey, Ted, you got a good group here. Did you get to see that? Okay. Well, he's going to quiz you, all right? So be ready.
All right. Hello.
Thanks, everyone.
All right. So hello. So I got 45 minutes. As of 5 minutes ago, I did not have a single technical diagram, but seeing Chris's presentation, I'm like, holy crap, I'm going to need some type of technical presentation here. So what I'm going to be talking about is the search for value, and what's that going to entail, right? But let me just go into a little bit of, if you don't know who I am, a little bit of background. So a long, long time ago in a galaxy far, far away, I used to work for a company called FINRA. If you work for Capital One, you may know FINRA. FINRA regulates the stock markets. So every stock that is purchased and moved within a broker-dealers and eventually given to a person is gone through this system called OATS. So you can think about it, billions and billions of transactions. And this system was built about a decade ago. So before big data was big data, FINRA had big data, right? And that's where I got to sharpen my teeth. And back in the day, do you remember back in the day when open source was not a thing? Like you weren't allowed to use open source? Do you remember that? Yeah. So at FINRA, we weren't allowed to use open source. So we actually wrote our own MapReduce and HDFS. And we identified that, hey, this is a real thing. And then I left and went to Cloudera. So I did Cloudera for about 4 years, and I got to work with everybody underneath the sun, including Capital One. I learned a lot from Capital One. Then the cloud started becoming a thing, and I became vested. So after that, I semi-retired, and now I work at Blizzard, which is my dream job. Has anyone ever played a Blizzard game? All right, so you totally understand why this is a dream job. So I get to do amazing things we're going to talk about in a little bit. And Blizzard has also been gracious enough, while video games is my passion, Blizzard has been gracious enough to allow me to be an advisor to a company called MetiStream. They're outside there, and we're going to talk a little bit about what they're doing in the Spark world. So my talk is going to be a mix of non-technical and technical. Because this is a Spark thing, let me just call out Spark is great. Spark is great for transformations and research and real-time stuff. I hope to God it will kill PL SQL. I really do. It's fairly powerful for doing graph operations and time series operations. And machine learning, while many may say the machine learning algorithms in Spark are not the most stellar, I saw H2O outside. Raise your hand, H2O. They would totally agree that the machine learning libraries in Spark are not up to par. But they offer a framework and some really good fundamentals where if you have a machine learning doctorate on your staff, will probably be writing their own distributed machine learning algorithms. And Spark is a good framework to do that in. All right. So let me talk a little bit about the state of my world at Blizzard. So there's all this going on. It's incredibly crazy. So first, there's a lot of legacy development. So what is legacy development? Well, before the cloud was about 3 years ago. So anything that's older than 3 years, right? IoT, maybe 2 to 3 years ago, right? Big data as a thing was maybe 5 years ago. Was anybody doing big data more than 5 years ago? I love the interview things that say you must have big data experience for 10 years or more. Like, what the hell? And then, is it language-based? How many people are doing low-level C++ and C code? All right. OK. So like game development, all C and C++ code, right? That's just how it is. Methodologies. Who has lived in the day where you buy an Oracle box and you paid a crap ton and it never goes down, right? Right? So that used to be a thing. And now it's like the test of how good your architecture is if you let a guy with a shotgun go into your server room, and you should still be fine, right? KS monkey, right? Yeah, so legacy development. The company's 26 years old. We invented video games over the internet. We invented Battle.net. So if you remember Battle.net, that was when people moved away from using these little cartridges things and playing with their little Nintendos to being able to play on the internet. But just to show you how much Blizzard is like totally engaged with their history, StarCraft was one of the very first Blizzard games I ever played. And I remember setting up little subnets in our dormitory to make it all work and stuff like that. Blizzard just released a totally remastered version of it so that it is 4K graphics, you can zoom in, zoom out, and they left every single conceivable bug and flaw that the original one had, so the gameplay is exactly the same, right? That's how much these people love their shit, right? They made it beautiful, but like the pathfinding from one place to one place has the exact same bugs that it had 16 years ago or so, and that's just how much they love their history. And all of this now is running in the cloud. We have what is that? That's almost a 20-year-old game running in the cloud, and very soon it's going to be auto-scaling based on demand. How many of you can say that you have a 20-year-old game that's auto-scaling, or 20-year-old application that's auto-scaling in the cloud and serving tens of thousands, if not hundreds of thousands of concurrent users? It's pretty badass, right? All right, so on top of like loving our history, we have lots of big stuff going on. So like active game development, we have Hearthstone. If you haven't played, it's a great card. It's the leading card app that there is, card playing game. If you've ever heard of, anybody ever heard of Overwatch? Yeah, so it won something like 120 best games of the year last year. I think there's only 120 like awards. So it did pretty well last year. And we'll go to the esports in a minute. The esports this year hasn't even started, and it's already like in the hundreds of millions of dollars. It's wonderful. There's World of Warcraft. Anybody played World of Warcraft? I think it's arguably to be said one of the most successful games ever in the history of gaming. And then you have Heroes, which is a leading arena type game, and then you have Diablo. I remember playing Diablo when I was a kid. It's like, you had to buy it without your parents knowing because it had like the devil's name on it, and my parents were like, you can't play that. That's the devil's game. But anyways, those are like in constant development, and they're all separate teams with hundreds of developers on each one of them, right? So it's a crazy environment. Then we have this thing called esports. People want to watch people play video games, right? So we have all this going around in the world, and we need to essentially become ESPN. We need to become the NFL. And all of a sudden, a game company just has to become a sports company. And that is a huge evolution for a company to go through. And you can imagine there is a lot of data that is involved with running that type of a business. The next is, has anybody ever heard of Destiny? All right. So Blizzard doesn't make Destiny, and Blizzard is not one to like host a lot of other games. But Destiny is such a great title, and there's such a great relationship with Blizzard, Activision, and Destiny, that Destiny is the very first game ever to now be on the Blizzard platform. And this was a big deal. If you ever, you're a bank, right? And if Chris came over to you today, is Chris still in the room? Oh, Chris not in the room. So if Chris came over to you and said, hey, Bank of America, Capital One, Bank of America is a really good client, and they want to give up their portion of their technical wing, and we want to host them as their fraud detection unit. How many of you would freak out with the amount of logistics and isolation and API compatibility? It's a big deal, right? So for 20-some years, Blizzard never let anybody in their shop, and now we're hosting third parties. So it was a big deal for us. And then new games. I can't talk anything about this. Or if there's even a new game. There's maybe no new games. Who knows? OK. So it's crazy. All right. So the big thing is there's totally multiple teams. Think about 20 or 30 totally different teams. It's, our organization, Donna was over there. Our organization, I would say, spans, I want to say like 6 or 10 football fields of buildings. So yeah, lots of security. It's like forever of just buildings. I think we're up to 22 buildings. So there's lots of people doing lots of things. So how do you solve that problem? And so let's first talk about big data, right? And where does big data fit in? Now, Chris had diagrams, so I made this sitting right over there. So this is the hottest, fanciest diagram in the world, and this is our pipeline, right? It doesn't have as many boxes as Chris, but it's not how big it is, it's how you use it, right? So let's talk about this. So while Chris's diagram explained where it was getting 12 terabytes a day, or like 24 terabytes a day, this sucker somewhere consumes somewhere around 200 terabytes a day. All right? Yes, we have tens of thousands of servers supporting the needs of millions and millions of players across the world. But you can imagine every single player is connected through a device. We need to know that their experience is good. So that means we're listening to every single device to make sure that they're getting the appropriate experience and they're happy. Can you imagine how much data that is? That's a lot of data. So all that comes into this one little pipe thing. This pipe thing's amazing. It just pipes. Then we have this thing called a schema repo, and Capital One has one too. But a schema repo in our world is we have all those teams. Anybody can make a new data set at any time without telling anyone, and it gets registered, and it's done. And it gets all the nice thing about like GDPR and all that gets reported, goes through auditing, all of that, and not a single developer has to touch a single thing. And it makes tables, and it makes collections in a reverse index system. It puts things in time series database in terms of metrics and entities. And it can do real-time detection. And all of that can be done without a single developer helping the team at all. That's badass. All right. So Capital One will be there. Give it a couple years. Not, just kidding. But it's very cool, and it's moving along. It's incredibly scalable, and it's incredibly isolated. So let's just say we had a third party, like a Destiny, that wants to use this. We can spin up a completely isolated pipeline for them. So it's pretty neat. And you can imagine, if there was a new game team, they probably wouldn't want their tables exposed to other people, right, to keep their secrets. So again, totally isolated possibilities, right? All right. And the goal is, by next year, it'll be able to run on any cloud. It'll be totally cloud agnostic. Anyways, OK, so big data. So let's talk about big data in terms of the principles of Blizzard. So the principles of Blizzard are think globally, lead responsibly, play nice, play fair, everyone's voice matters, gameplay first, and learn and grow. So think globally, right? So people play our games all over the world. And we need to bring all that data back together. We need to bring it all and have a coherent view of what's going on. We need to be able to know the health of every application, down to every server in every region, and be able to say, hey, there's a CPU problem on this box. How do we respond, right? We need to store it correctly and responsibly. Every government has different rules upon how their data is to be taken care of, what's the TTL, and stuff like that. But in the same sense, the system has to be so easy to use that game developers that don't give a crap about any of this stuff need to be successful, right? They need to be able to put their data in and get the value out. Lead fair and lead responsibly. Lead responsibly and gameplay first. So one of the biggest things at Blizzard is making the game fun. And one of the things we do with Spark, and this is a big one with Spark, and I can't tell you what we're doing, but I can tell you we're using Spark, is we can identify the user patterns of people and how they're enjoying the game and how their approaches to the game are successful or not successful. And in doing this, we can either modify the game or help the user modify their own strategies so that they're having a better experience with the game overall. And this is huge. We can understand who the players are, and we can actually go down at any time and drill down from a meta and go down to a single user and see how they're doing at any time, all the way up and all the way down. Because every person to us is important, and we want their experiences to be good. This goes to play nice, play fair. There are cheaters, and there are trollers, and there are toxic behavior. And we're trying to keep mindful of this. We're trying to control, we're trying to understand where they are, what makes people toxic. Sometimes they even are very nice people. But the environment of the internet and feeling like you're anonymous, people behave differently. So how can we create environments with better people and better players, which produces a better outcome? Every voice matters. So one of the sayings I've heard a lot of people say at Blizzard is made up of scientists, adventurers, and oddities. And that's one of the slogans behind this Overwatch game we have. And the idea of big data is to be able to listen to our players. When you have hundreds of millions of players, it's very hard to hear through all the noise. And that's what this gives us, right? And it's important to collect, when he talked about up here about listening to doors open and doors close. Yeah, we listen to everything, right? In a responsible way, to make sure that everything is running well on your system. And we get alerted on it. And then learn and grow. So one of the big things that Blizzard has had to learn recently, and I'm sure you guys all know it, is when you write something the first time, it isn't like the perfect solution. And you might have to iterate. And this is one of the things that we're getting much, much better at, just changing really fast. And what Spark allows us to do, in the old days, if you're doing machine learning, let's say you had like R on somebody's laptop. This is actually a real example. On one of our games, we had this meta discovery piece that helped us be agile in terms of our gameplay. It took 2 to 3 days to run a single job to see how things were going. Now just think about this in perspective of a launch. Let's say you launched a new game. You don't know if the gameplay is balanced for 2 to 3 days, right? Using Spark, not only have we gotten that down to 5 minutes, right? But now, because we've built up a educated base with Spark, if something's wrong with that, they can adjust that code almost immediately and react. So extreme differences in performance and being able to do iterations and such. All right, so this is one of the big things I want to talk about. So one of the big problems with big data is all about big data. It's not about, a lot of times people don't talk about the outcomes. And now Chris did a great job talking about the outcomes. But it's one of the things that Blizzard really tries to focus on, is why are we doing such a thing? What are the goals? What are the endpoints? And how do we draw those lines back, right? And in the end, if you can't explain what you're doing to the CEO who doesn't give a crap about Spark, and he isn't excited or she isn't excited, then you're not doing something right. And that's one of the premise of what we're trying to do. We're trying to make sure that our data, our CEO even, could go in without any, I don't know if you know SQL, but without any knowledge of SQL or Spark or anything like that, can discover the health of the entire ecosystem of every server in Blizzard and the happiness of every single player while they're playing without having any technical ability. And how do you organize your data up front and correct the right metadata structures, the right information architecture, and the right user interfaces to allow anyone in the company to help make the company better? Any question? OK, it's OK, keep going. So IoT. So who in here is like, IoT was a new thing, and you're like, was that really a new thing? Like, it was just like, because it became like this IoT, and it's like, what's that? Information is coming over a wire. I'm like, wow, is that new? When did that become new? So anyways, it became new, and now I guess it's like magnitude that made it more important, right? So everything that we're doing is streaming. We have very few things, I could probably count them on my hands, that are batch. Everything comes in streams. Everything is real time. Everything is reactable real time. Everything is viewable real time. OK, in the cloud. Now, when I made this slide, I was like, I could put a picture of a cloud there. There's a really cool city in Overwatch that floats in the cloud. And I was thinking about doing that. But then what I did was I put Argus. And Argus is a planet that was devastated because of the fear of corruption and because of chaos, it got just massively destroyed. And now it's this wreck of a planet. And that really reminded me of what the cloud is today. Where at one point it was this beautiful environment that everyone was, it was super promising, and then you do something wrong and your CFO gets the bill, and holy moly, it's an interesting discussion. So the idea here is, are we provisioning correctly? Are we auto-scaling correctly? Are we listening to the new patterns like Docker and container and stuff like that? Does Kubernetes have a place? Is Kubernetes wrong for us? There's a lot of interesting stuff happening at Blizzard around the cloud. Do you trust a single cloud vendor? Actually, we can't trust a single cloud vendor. Do you know why? A single cloud vendor is not in all the places where our games are. There's no single vendor that can give our games a good experience. So we are forced, just by that, to have to be multi-cloud, multi-data center, multi-everything. Because in the end, the user experience is key. I'll give you an example. There was a great game, I think it was like Ubersoft or something, that came out, which was like For Honor. And it looked amazing. If you YouTube it, it's like, oh, it looks so beautiful. And when people, and it immediately dropped in usage, and it's like essentially dead now. And it's because all the player-to-player interaction was crap. And so keeping that connectivity and the low latency and the interactivity as high quality as that's like a bar is key to making your players happy. So to us, there actually is not a cloud vendor that can meet all of our needs. So that just is our reality. Right? Now, if you have a website and somebody does a credit card transaction and you have a whole second to respond, in Overwatch, it's 120 frames a second. So that means you must return the entire state of reality back to every single client in less than, 8 milliseconds, always. Like that's a high bar, right? And if you can't get a data center in the country and you got to go over multiple hops, you're not going to get that. The other thing is just sharing resources. Back in the day, you guys are in the cloud, so this is no big deal to you. But back in the day, you didn't get that. Be able to, have databases that can scale and run in the same hardware that other people are using, standardizing those things and stuff like that, moving away from the big appliances to stuff like Cassandra and Kafka and beautiful things like that. And then microservices. So while we use Spark for a lot of places, all our data prep is in Spark. A lot of machine learning is in Spark. A lot of analytics is in Spark. A lot of time series stuff is in Spark. But I have a talk at Strata Data where I talk about don't use Spark for a lot of things. And one of the things is for microservices and streaming. There's a lot of use cases where you don't need anything but a microservice. And I'm in love with, who loves microservices? OK, come on. They're awesome, right? You get your containers, you get your scheduler, and boom, you're there. And actually, it's the fastest, simplest thing you can do, right? So we are really pushing the envelope on microservices at Blizzard. All right, so now I'm going to switch gears for 1 second. I'm just going to talk about MetiStream. So while I love video games, and video games is amazing, healthcare is a big thing to me, right? If anybody's ever had anybody die of anything, healthcare probably is relevant to you, or you have no empathy, right? There are some people I've met along my Cloudera journey that really care about healthcare, and they have a pretty good vision, and I really like their vision. And Blizzard has allowed me to be a advisor for them. And here, actually, Donna and Nathan are at Blizzard. They came and visit me. If you're interested, yeah, Blizzard campus is wonderful. We're 20 minutes from the beach. We're 25 minutes away from Disneyland. And it is sunny 300 days a year. And there's no humidity almost. It's like maybe 1 month there's some humidity. Yeah. So it's a really terrible place to live. Yeah, if you hate sun and the beach and Disneyland, it's terrible. Anyways, but MetiStream, it's very simple, right? They ingest medical data from multiple sources, so they can work with universities, they can work with hospitals, they can work with a number of people. They can ingest the data. They are heavily based on Spark. They can learn from the data. They can create models from the data. And in real time, they can help doctors classify where people are, what are they most risky at. They can develop advisory plans for how can they change their life for the better from where they are, based on things like their genomic code, their current health status, and their historical health status, and help personalize a journey for them for a more successful life. They're dealing with things like diabetes, veteran suicide, things that actually matter, right? Not that video games don't matter. Video games is why we live, and they're going to help us live longer so we can play more video games. But they're over there in the booth. Please check them out. And they've been helping support the Spark community here for a long time. All right, so what didn't you hear me talk about? This is the second of all of the ever presentations I've ever done that I did not put a code example in. And what I wanted to do was step back a second and experiment with the idea of not talking about detailed implementation. I actually wasn't going to have that architecture diagram in there, but Chris just overwhelmed me with all of his squares and dots and all that kind of stuff that I felt obligated. But what I wanted to talk about was the idea of focusing on value, and remember that these are tools, right? Now, Spark is a very good tool, and we use it for what Spark is good for. The main thing is there should be no love for a tool, right? A tool does its job, and you select a tool because nothing else can do that job except for that tool. And the fact that Spark is in our architecture, and it is pretty heavily, means that as much as I know it and hate it, it is the best thing that can be in that position. It just is. So, and you notice I didn't say anything lovely about any cloud vendor. And yeah, I think that's relatively good there. All right, yeah, dream big. These things that everyone talks about at conferences, about having full visibility of big data and learning from it in real time, and having the ability to have free schemas and people access it in isolation, you can do this. It's not that hard. Well, actually, it is pretty hard. But you can do this, and it is doable. While I think Blizzard is in a good place, in a year from now, I feel like Blizzard's going to be, yeah, I mean, I've had conversations with Netflix, and I feel like in a lot of areas we're doing better than Netflix. I feel very positive about where we are. But we don't necessarily tell people because we're very quiet. Okay, the other thing is always quantifying value, right? That's the huge thing. Stay away from the technology mumbo-jumbo of AWS is great or Spark is great. Value, right? Deliver continuously. This is one of the reasons why we love Spark, right? With the UIs and the quick coding and using SQL interactive with machine learning and with graph analytics. I have had sessions where I literally sit down for an hour. I actually did this like last week. It was Spark. I had the data sets. We sat down for an hour, and we did network clustering and figuring out the strengths of network to do causations in health related to toxicity. And we were able to get from tables to Spark all the way to a D3 directional force graph within an hour. Now that's badass, right? And then just continue to learn. Everything you know now sucks, and if you can't look at your code and your architecture and say that it sucks, you're delusional or you're missing something. All right, that's pretty much all I had.